Hi there, my name is Ian Lawson. I'm a Principal Domain Solution Architect working for Red Hat. And today I'm going to talk to you about there is no such thing as vanilla Kubernetes. And the reason I'm going to talk about this is that it is a question that I get asked in every customer engagement I actually go to. And my answer is going to tell you why OpenShift4 is the Kubernetes for enterprises. So to start off, first of all, Kubernetes is the future, period. It's a fantastic piece of software. Cleverly engineered, it does things the way developers expect it to do, and it addresses the major problems we used to have with container orchestration. And it's absolutely fantastic, but there's a small, slight problem with it. And that is, it's huge. This picture here shows you a selection of all of the projects that actually make up Kubernetes. There's something called CNCF, and CNCF is a body that actually controls which products actually go into Kubernetes. And all of these projects and products at some point actually integrate and form the Kubernetes ecosystem. It's absolutely huge. So what I'm going to do is I'm going to explain the differences between Kubernetes itself, vanilla Kubernetes, and why there isn't such a thing as vanilla Kubernetes, and the Red Hat OpenShift platform. And I'm going to do it using customer questions. So what I've done is I've actually taken questions I've been asked in the field, and I've actually provided them with answers to show you the differences. So we'll start with a nice simple one. Isn't Kubernetes free? That's a zero cost, right? Well, absolutely right. Kubernetes and OpenShift are both open source. And what open source means is you can download the source for them. And that's it. You have to build that source code. You have to maintain the built artifacts. And every time the code changes, you have to rebuild it. And if you remember, going back to that slide of all the projects that make up Kubernetes, there's a lot of stuff under the covers. Now, OpenShift out of the box, we provide for you. You don't have to build it. So it comes, it installs itself, does all those kind of things, and it's predefined. So you have to set up the configuration of Kubernetes. I'll give you a good example of this. There are thousands of options when you set up Kubernetes. And if you miss one, you're exposing a security hole. And you have to maintain that configuration if you're using vanilla Kubernetes. And it comes down to the fact, do you want your staff maintaining a platform, or do you want your staff generating revenue? Now, OpenShift, when you purchase OpenShift and actually download it and install it, it installs very, very simply, and it comes pre-configured for enterprise. It comes set, maximally secured. It comes with all the components you need, and it's actually following the cadence of Kubernetes. So there's the difference between an open source project that you actually have to download and build yourself and a product like OpenShift. So Kubernetes is free. Absolutely. It's open source. But that word free doesn't cover the cost that you have to do to actually build it, configure it, maintain it, and do all those kind of things. But surely I get everything I need with vanilla Kubernetes. Well, yes, you do. You know, Kubernetes is an entire container orchestration platform. But you don't get everything you need for enterprise. And what I mean by enterprise is the simple things like security, like logging, like being able to monitor what's going on. And OpenShift provides these essential features out of the box. You don't have to pick and choose what you need or actually install it yourself. And I'll give you a good example of this. If you let's say you download and install the basic Kubernetes. The first thing you see is that there isn't a security model, so you have to put your own security model on top of it, authentication, lock it down. You then see that there isn't the kind of logging, integrated logging across the entire platform you need. So you download Prometheus, install Grafana, set up all those kind of dashboards so you can see what's going on. You then see that the underlying operating system is actually abstracted away from Kubernetes. Kubernetes can't see the actual underlying operating system. And so you look at the operating system, you have to patch that operating system, you have to follow the release cadence for the operating system itself. And suddenly you don't have vanilla Kubernetes. You have Kubernetes with all those additional things you've added that you have to maintain and patch yourself. Now with OpenShift out of the box, they all come integrated. They all come as standard. So when you install OpenShift, you've got Prometheus across the board. Prometheus monitoring metrics on all the actual applications that are running, monitoring metrics on the actual nodes on which OpenShift is running. And the security model comes out of the box, and also it has a plugin authentication model, so you can choose which authentication supported you can use. So you can authenticate by HTTP if you're brave. You can authenticate by Active Directory. You can authenticate using RHSSO. And that authentication works across the platform and it's fully integrated. But once you get into the platform, you have this concept of an RBAC control model. So Kubernetes itself is a set of objects. That's all it is. It's a set of objects held in a brain and a control plane that actually allows you to change the state of those objects. What OpenShift allows you to do is to apply RBAC across the objects themselves. So you can specify exactly what users can see what users can interact with what. You can isolate individual namespaces, isolate projects. You can make them physically invisible to other namespaces or projects. You can use labeling within OpenShift to actually move applications to specific nodes and abstract those nodes away. So you can do some very cool things all out of the box. And with Vanilla Kubernetes, you'd have to add these things and maintain them. And every one of these things you add has its own release cadence. And literally, I've talked to customers where it's become a day's job or day-to-day job to actually maintain these platforms. And they have teams of people maintaining the platforms. And as I said previously, wouldn't you rather have those people generating software to generate revenue for you? The whole point of OpenShift is it fast-tracks the ability to use Kubernetes, and it controls and contains, if you don't mind the pun, the use of Kubernetes. So, Kubernetes is easy, right? And I say I've heard this from a number of different customers. The theory behind Kubernetes is easy. It's a very clever system that allows you to orchestrate containers over multiple hosts. But the way that Kubernetes is built is it has a control plane that you talk to, and it has a brain which contains the objects, which is the current state of the system. And when you're talking to the control plane, what you're doing is you're changing the state of those objects. And in the background, Kubernetes and OpenShift, because OpenShift is built on top of Kubernetes, are actually resolving the changes to those object states. Well, that sounds a bit wordy, but it is quite simplistic. But if we're going to be honest about it, wrong. Kubernetes is fantastic, but the power of the system comes with and from that complexity. Kubernetes, if you can imagine it, is a fantastic engine. But what it's missing is the car around it. What it's missing is the ability to control it in a way other than reaching into the engine and pulling the valves and doing all those kind of things. OpenShift is Kubernetes, but it's wrapped, enhanced, and improved in terms of the ease of use. One of the major design points we had around OpenShift was to make it easy onboarding, because Kubernetes is very, very clever, but very, very complicated. But what we've done with OpenShift is we've made it so it's very easy to actually get onto it. It's very easy to use it. It has an opinionated interface that controls the way in which you actually get at things and the way in which you interact with it. But it is as complex as Kubernetes if you want it to be. If you want to dive under the covers and use the command line, well, we've got a command line called OC, which is the same as kubectl, but it adds additional features from the OpenShift side. If you want to do that, you can do that. If you're comfortable with the complexity, you can actually do that. These opinionated interfaces we provided don't limit the functionality of Kubernetes. But it can also be easy, if you need it, through the opinionated interfaces, both for development and administration. And what I mean by that is it's incredibly easy to pick up. It's incredibly easy to control. It's got a massively powerful interface based on the Tectonic stuff from CoreOS who we acquired. And it is a very, very nice way to get into the concept of Kubernetes without drowning in that complexity. Because Kubernetes isn't easy. And you can see that by the skill sets that are currently in the market. People are dying to get up to speed on Kubernetes. And as soon as they get up to speed on Kubernetes, they're being sucked off into special organizations to work purely on Kubernetes. So the normal people in the street that want to use Kubernetes, it's a very hard onboarding process. And again, OpenShift allows you to fast track that through very cleverly written opinionated interfaces. But why should I pay for a Kubernetes distribution? Kubernetes is open source. You know, why should I have to pay to use that kind of functionality? Well, absolutely, you do not have to. You know, we're not saying you have to go and purchase Red Hat OpenShift if you want to use Kubernetes. But if you're going to use Kubernetes, if you're going to use vanilla Kubernetes, or even if you're going to use an enterprise distribution of Kubernetes from one of the cloud providers, you are going to face the costs of installing, maintaining, and curating a Frankenstein Kubernetes. Because the tools you need to do your job, and the tools your developers need, and the tools your administrators need, they're not there in base Kubernetes. You have to install Prometheus, you have to install Tecton, you have to install all those additional features. If you buy a managed Kubernetes distro, you negate some of that, but you still have the complexities of native Kubernetes. It's a wonderful system, but it's incredibly complicated. With OpenShift, you get peace of mind, an easier adoption route for Kubernetes, and all the additional enterprise strength features that we think you need. The security side, the ability to monitor, maintain, the ability to spin up and spin down nodes from the user interface. All of these things through a fantastically opinionated user interface. But at the end of the day, it's your choice. You can choose to actually deal with the complexities of Kubernetes, or you can choose to deal with OpenShift. So Kubernetes is open source, and OpenShift is proprietary, right? And you'd be surprised how many times I get asked this. Now, Red Hat is, at its core, an open source company. Everything we do releases open source. All of our engineers for OpenShift are Kubernetes contributors. Every time we add something on top of Kubernetes for OpenShift, we actually push it back into the community if they want it and if they want to take it. We're not proprietary. Both OpenShift and Kubernetes are open source, as I said, and OpenShift builds upon, secures, and enhances Kubernetes. Red Hat are massive contributors, as I said, to Kubernetes, and OpenShift provides additional objects to simplify and enhance some of the Kubernetes functionality, such as routes and deployment configs. So what we've done is we've extended the objects within Kubernetes. Using the new operator framework, this is easy. In the old days, when we had OpenShift4, we had to build those changes into the Kubernetes codebase. And that made it a complicated beast and made it quite hard for us to follow the cadence of Kubernetes. So whenever Kubernetes was updated, whenever Kubernetes changed, we had a bit of a job in actually re-engineering the OpenShift executables, deploying them and all those kind of things and testing them. With the operator framework, what the operator framework allows you to do is to extend the object model of Kubernetes without extending the object model. You add additional objects that can be handled in the same way that Kubernetes handles objects, but you run an operator to do it. And an operator becomes a custom controller. Because if you remember what I said, Kubernetes is a set of controllers. Each of these controllers is effectively a while true loop. And each of these controllers owns an object type. And each of these controllers look for creation of a new type of that object or changes to an existing object of that type. With an operator, you add additional objects. You add new functionality. And the nicest thing about OpenShift4, which always blows my mind, is that OpenShift4 itself is a set of operators running on Kubernetes. So you have your base Kubernetes. You then have what we call cluster operators, which add additional new objects into the Kubernetes object model and provide controls over them. But all the additional features of OpenShift, the security, the registry, the API itself, they're run as operators. Now, the nice thing about that is it means that OpenShift itself deploys on Kubernetes. We do the deployment through our installers, but it means we don't have to change the base Kubernetes for the OpenShift features. And that reduces the complexity. But going back to what I was saying, it's not proprietary. Red Hat OpenShift, you can go and download the source today. Only yesterday, I actually downloaded the GitHub repo for the actual OpenShift user interface because I wanted to look at how it was doing things. I wanted to see if I could change some of the styles. I wanted to see if I could move things around. And I can actually take the user interface code, rebuild that user interface code into the appropriate container and deploy that container as an operator onto my instance of OpenShift. It's not proprietary. It has additional features above and beyond Kubernetes functionality. And I've had a couple of customers ask me who've come from Kubernetes backgrounds, and they've said, we want to move to OpenShift, but we're afraid when we do, we're going to get locked in. I said, well, that's not the case. We're not proprietary. Which brings me on to this one. But am I locking myself into OpenShift if I choose that rather than vanilla Kubernetes? Again, a pure customer question. OpenShift is Kubernetes. Under the covers, we're running Kubernetes. We talk Kubernetes. We use operators to extend it. You can download additional operators from the operator hub and actually use those to add additional features to your system. But at the end of the day, we conform to the Kubernetes standards. The additional highly useful features that we provide, they're all optional. So you don't have to use routes to ingress traffic into your OpenShift cluster. You can use ingress controllers. You can set up custom ingress controllers that behave the same way that your original vanilla Kubernetes does. Or you could use routes. Routes are a much better way to do it, a much more controlled way of doing it. But you don't have to do it. And if you stick to those original vanilla Kubernetes objects, you can lift and shift workloads back and forth between OpenShift and Kubernetes. There is no lock-in to the way you can actually produce applications, write applications, and deploy them to OpenShift and Kubernetes. It's not a lock-in to go down the OpenShift route. But these are just words. I mean, if you go, there's a website called try.openshift.com, which actually has links to all of our installers. And the installers work. We've got two different types of installation. One's called installer provisioned infrastructure, and one's called user provisioned infrastructure. We've done that because we have certain archetypal deployments, let's say Amazon, Azure, VMware, bare metal, OpenStack, Red Hat virtualization, where we can produce the installer provisioned infrastructure mode for it. And what that does is it gives you a single executable. And then you run that executable, you provide it with the appropriate credentials for your target environment. So give you a good example here. If you wanted to install OpenShift4 on AWS, you simply download your AWS credentials, you set those up, you then run the installer, and the installer uses your credentials to spin up what's called a Bastion machine. That Bastion machine then spins up 3 additional machines and pushes the cluster operators that make the masters to those. So it fires up individual machines using kubeboot, runs a Kubernetes control plane, installs the master operators. When those master operators all report back as being healthy, the Bastion closes connection and makes those 3 masters the masters. The masters then can kick off additional nodes, and they'll install them automatically using whatever platform they're on. And they actually then flow the actual cluster operators for the nodes down to those. And when all of those report as being healthy, your system is installed. What's nice about that is you can then go into the system with an installer provisioned infrastructure mode and choose to scale up or scale down the nodes from the user interface. And we've got things called machine sets, which allow you to choose what flavor of the worker nodes you want to create. And you can even set auto scalers automatically for those nodes, depending upon the node's behaviors. So using the IPI mode, it gets around all those problems you had of installing a vanilla version of Kubernetes. You don't have to know how to install Kubernetes. You don't have to know how to install OpenShift. Now, there are some situations where you can't do that, where there are platforms that we don't currently have an IPI mode for. So we provide a UPI mode. And all a UPI mode does is it does everything the IPI mode does after the creation of the machines. So you physically create the machines yourself. You then provide the information for those machines into the installer, and the installer will flood and flow OpenShift down onto those machines, which is the UPI approach. And the nice thing about the IPI approach compared to the UPI approach is it's very standoff. You run it and away you go. But going back to what I was saying, everything I've said so far about vanilla Kubernetes versus OpenShift, you can go and try it. Go to try.openshift.com. You need to have a Red Hat account, which is free. You would get your Red Hat account, you log on to try.openshift.com, you follow the actual menus within the website, and you get the installer, and you can then run the installer, and it will install OpenShift for you. Going back to the vanilla Kubernetes side, I'm a huge Kubernetes fan. I love Kubernetes to pieces. It's a wonderful intellectual experiment. This idea of being able to abstract your way away from the actual physical instantiation of the containers, the wrapping in the pods, the deployment of the pods, the fire and forget nature of it. It is the future. It is the way to do things. That abstraction, that getting everything through an API. But as I said, it's a box of technical Lego. It's a very, very complicated beast. And I'll give you an example. I won't give you the name. There was a customer who went down the vanilla Kubernetes route. They set up their entire systems, their back-end storage, their front-end web servers, all that kind of stuff. And they missed one configuration option out of the thousands of configuration options. And that one configuration option they missed was to set a password on the masters, on the actual the control plane itself, the control plane user interface. And within 5 minutes of it going live, they had people in their system. And that was one configuration option. Now imagine there are thousands of those. And imagine also Kubernetes and Docker are both security agnostic. And the reason they're security agnostic, quite rightfully so, is security is hard to do. So rather than overcomplicate the actual the project code itself, you push security out. You say this project has to be run on a hardened box. And most people don't do that. They just install Docker. They install Kubernetes. On Docker, the containers can run as root. On Kubernetes using Docker, the containers can run as root. That root isn't root within the container. That's root on the node. That's root on the host. Now, OpenShift takes a completely different approach to that. OpenShift locks everything down out of the box. So what it does is basically when you try and do something with OpenShift that's outside the box, when you try and run a container as root, it stops you. Now, that might sound a bit restrictive, especially if your container has to run as root for a part of its process. A good example of this is I had to port an Oracle Apex application onto OpenShift. And the first thing that Oracle Apex does when it runs up is it sets the group ID of the process. It sets the group ID of the process to be Oracle as opposed to whatever it is before. So it can identify all the processes that are running as Oracle and share resources and things like that. By default, OpenShift doesn't allow you to do that. It does not allow the containers to change the actual group ID. But what you can do within OpenShift, because of the role-based access control model and because of the approach we've got in terms of security, is you can actually lessen the security for that container by name. And I'll tell you very, very quickly how you do it technically. You set up what's called a service account. A service account lives within a namespace, lives within a project, and it actually physically interacts with the objects within that namespace. By default, interestingly, you get a service account in OpenShift called default. And that default account has access to do things like do the build, do the deploy, do all those kind of things that need to be done within the namespace. When I ran this container that required a little bit more security, I had to write a specific service account and give it what was called a security context constraint. And that security context constraint said that that service account could set the group ID for the container, but nothing else. It disabled all the other setcomp profiles. It removed the ability for it to add users or mount file spaces, all those sort of dangerous things. So it allowed it to effectively run as root. So it ran as a privileged, and it allowed it to do that one setcomp thing, which is change the group ID. And then it ran fine. And the nice approach of that, and what highlights the security aspects of OpenShift compared to Kubernetes, is that with the control with the service account and the SCC, that just opened that container in that namespace. I didn't have to break the security model across the namespace. I didn't have to break the security model across OpenShift. And that's the difference. With Kubernetes, it's a fantastically complicated tool, but it's open because it has to be open. People have to be able to add operators. They have to be able to interact with other namespaces. They have to be able to do things at a cluster level. With OpenShift, you don't. OpenShift locks down the users so they can't run things as roots. You can lock them within namespaces. You can lock them within projects. And that's an enterprise approach. And that's the difference between running a vanilla Kubernetes and running OpenShift. But going back to what I was saying about what this whole slide deck was about, there is no such thing as vanilla Kubernetes. Vanilla Kubernetes is a very, very complicated box of technical Lego. And you have to build a model to get it to run. And you have to do that if you get vanilla Kubernetes. If you go down the OpenShift route, out of the box, it's there for you. All the things you need, the monitoring, the security. And that's the difference. I say thank you for your time, and please go and have a play with it on try.openshift.com.